Since my channel is military focused, I assume most of you guys already know who Eugene Stoner is. For those that don't, he's the man behind the AR-10, M16, and that one really cool assault rifle from Black Ops 1. Even if you already knew that, you probably didn't know he designed the XM274 automatic cannon, which was mounted on the HIMAG, HSTV-L, and RDF-LT. I guess the modular assault rifle wasn't cool enough. He had to make an automatic tank gun too. Stoner gave an interview about it with the Smithsonian. I was able to get my hands on it, so I figured I should share it with you guys. It's really interesting, and helps explain the general concept a bit more. Anyway, I'll shut up and roll the interview now.
Alrighty, now we've moved on to something even bigger and better in a sense. We're looking at the breech mechanism off of your 75mm automatic cannon. Can you start off with a little bit of history of this project, when it got started and what you were trying to do?
Well, originally, this goes back quite a few years, DARPA was trying to find an alternative anti-tank system that didn't depend on a heat round or shape charge technique. They were afraid that one of these days somebody might develop armor that could defeat that. And so they wanted a anti-tank kinetic energy round system. And with that, they also wanted, in particularly, a high rate of fire system. In effect, a machine gun that could defeat tanks, because in a mass armor attack, tanks could be coming in such great numbers that they could overrun conventional single-shot type systems pretty easily, and they'll have to have something with a very high rate of fire in order to hold its own. So we started out, we had this concept on this type of a system, and they also wanted to incorporate telescoped ammunition. So we came up with a couple of designs. This one was the final evolution of that design, using telescoped ammunition and literally making a machine gun of this size that would fire it. Originally, everybody thought that 60mm would probably do the job, but then at the last moment before the contract was let, they requested that the size go up to 75mm. And even the 75mm, we've actually changed, I think, the ammunition configuration, I think, 3 different times in order to accommodate a more powerful round than original.
What does the projectile look like in this round?
Well, we fire basically 2 types of projectile. We fire an HE projectile, and we fire a armor-piercing, discarding sabot type projectile, fin stabilized. So in effect, we're firing a typical long, L over D type of a system, and we fire it through a smooth bore. This weapon doesn't have any rifling in it whatsoever. The whole idea of using the telescoped ammunition was the fact there again we could use a push-through type principle where the incoming round could literally push out the expended case. In this case here, you're seeing the breech in the loading position, and the rounds would normally be loaded from down below, and they'd actually push this expended round out the top of the weapon. And one of the reasons that I chose this type of a breech mechanism, which is literally a pivoting type of arrangement, as you see here, it goes down to and lines up with the barrel to fire and then comes back in the vertical position to load, is it greatly simplified the other part of the system, which was the ammunition feeding system and magazine system. In this case, where the rounds are, average out around 40 pounds apiece, this becomes quite an important factor. And what this did, by being able to tilt this breech, it literally took out, I would say, at least half or maybe 3/4 the amount of machinery it would take if it was a normal breech loading conventional system. So it greatly simplified the ammunition handling part of the system. It also, part of that is complicated by the fact that the gun has to elevate it originally at very high angles, and we had to have a system that was compatible with that. So this swinging or rotating breech actually contributed greatly to the ammunition feed system.
What kind of rate of fire can you obtain with this type of mechanism?
We've actually, in tests, we've fired them up to a rate of 2 rounds a second. And nominally, well, I think we're shooting about 1 round a second or maybe a little less now. And that limitation was put on greatly by the fact that the fire control system and stabilization system and everything had a difficulty in keeping up with any more than that. So it's turned out to be a fairly good rate.
What kind of rate of fire do they normally get out of a standard tank?
Well, in the standard 105s and all, I think that they're probably less than half that with an automatic loader. They probably take at least twice as long to do it.
Hand loading them?
Even with an automatic loader. Hand loading, I think you're up considerably longer than that.
Plus you have the human fatigue factor.
Well, that, and you also, in that case, you have an extra man in the tank, which contributes several tons to the weight of the tank, just putting that extra man in there and protecting him with armor. So this system lends itself to a complete remote system, which we have developed, where there are no men in the turret whatsoever.
Does that have the advantage of being able to move the ammunition storage closer to the gun, or at least some of the ammunition storage closer to the gun? So
Yes,
you don't have to move it around as far in the vehicle?
That's right. It's a much more compact system. It also gives us, this system also has a capability of giving us a mixture of ammunition that the gun can discriminate which type it wants to shoot, and makes that readily available.
How does this overall system compare in weight with conventional single shot systems?
Well, actually, this system as it is here is fair, consider the fact that this breech mechanism also includes the recoil mechanism, and actually we're talking about approximately the same weight as a single shot system, all up single shot system. There's a much.
When you get into when you get into the conventional systems with auto loaders, you're really saving weight.
I think we are over the where we're handling conventional ammunition. We've had experience here building both types, and I don't think we don't have the 105 system here now that we've developed, but it's interesting to see the two side by side. You can draw your own conclusions. One of the things we can do on this is the fact that this tilts, this weapon doesn't have to go back to a zero position to be reloaded each time like most autoloaders do. In fact, what happens is that this tilting of the breech makes up for the difference of angle that the weapon might happen to be pointed, which is kind of unique in that position, so that it saves time and loading, and also greatly simplifies the loading system.
Could you lift that heavy 40-round empty shell there so we could sort of see what the shell looks like in relationship to the weapon?
This is what the shell looks like, and you can see it has hemispherical ends on it. That's the reason that if you project this around, would be a sphere. And this is just taking a section out of the sphere. That's to make everything fit when it rotates in position to fire. It takes up all the gaps and so forth. The shell or the penetrator is placed down inside of the round of ammunition, similar to the one that you saw in the cutaway of the 25 millimeter. So it's all buried inside, and you have to really look inside the round through this hole to know whether it's a loaded round or not. You can't tell by just looking at the outside. This happens to be an empty one now. It has metal end caps on it. This happens to be a plastic case, and the metal end caps do the job of sealing up under the high pressure gases.
Now, with that type of projectile, do you get much heat transfer into the breech block?
No, practically zero heat transfer during firing, because there isn't any hot gases washing on the breech block at all. So the barrel takes all the gas wash, and that's therefore the heat sink, and you get very little transfer back into the breech itself.
So you don't have to worry about things like cook-off, and
No.
you can keep up a fairly high rate of fire.
That's right.
So in a combat situation, you could actually use this at the rate you need to and not have to worry about shutting it down at some point.
Yeah, you don't have to worry about cook-offs, and that's not one of our safety considerations on this.
A moment ago, we were looking at the breech block, Now, how does that breech block relate to the housing in front of you?
Well, this is what we call the receiver assembly, which is a part that actually takes all the parts of the gun, including the barrel and the receiver. And the breech block that we saw a moment ago actually slides right inside of this unit here. And this shell then has a back cover on it. And this actually protects the gun mechanisms from the elements. And in this case, it also has to be certain thickness to take fragmentations and everything from enemy action.
Before we were discussing new materials and new technologies. Is something like this receiver or the forward housing for the barrel, is any of that candidate for using composite or other new materials?
Yes, it is. In fact, we have made the barrel jacket, which is actually from this part forward that supports the barrel, out of composite, some of the later composite materials, and it's worked very well. In fact, there's probably no reason why we couldn't make this whole outer shell, and we looked into that, out of a composite material. We could save a considerable amount of weight. But part of that has to be also traded off on the customer's requirements on frag protection and so forth.
In having a couple of conversations with some of your engineering staff, the comment has been made that in all of your designs you are weight conscious, and that sort of reflects your origins as an aircraft industry person. Could you comment on that?
Well, yes. Actually, when you consider that any piece of military equipment now in the weapons field is eventually going to have to fly, and therefore weight is a big consideration. So I think that even in this case here, the vehicle this goes in has got to be air transportable. So it's extremely important to keep the weight out of the system. So it does have it has a purpose, watching that weight, and you really have to watch it.
That's one of the consequences of shifting from air transportation of hardware from where we used to use ships before.
That's right.
And also the demand for rapid deployment.
That's correct. That's particularly so, the larger the caliber gets. And then when you get into small arms, you've got the man to worry about and what he can carry. But that's all. I've always considered that rather a joke, because every time they take a pound off of the weapon, they give the man an extra 2 pounds of something else to carry. And his combat load hasn't changed one single bit in the last 50 years. It's still the same, even though he has a much lighter weapon system.